Hello, the purpose of this video is to summarize and to review the quotient rules with coefficients. Just like we did when we did the product rule with coefficients, we're going to see what happens when we have expressions that have coefficients that are dividing, like monomials that are dividing. So we're going to do three examples, and we are going to briefly review the first one with expanded form and then the quotient rule. And after that, we're just going to use the quotient rule because we already discovered it is more efficient. So here's the first example. 4n exponent 5 divided by 2n squared. So for us to see it in a detailed fashion, we could do expanded form, which means we take 4, multiply by n by itself 5 times, divided by, we write it like divided by 2, multiply by n 2 times, and we can see that the two n's that multiply in the denominator cancel 2 in the numerator, and at the end we end up with n cubed, and we just perform the division of the numbers. 4 divided by 2 is 2, so this is our final answer. And if we were to do these with quotient rule, which is a little bit more efficient, we know that our quotient rule states that when we have the same base and two power expressions are dividing, we subtract the exponents. We keep the base the same, subtract the exponent, and we did this here. We rewrite these like 4 divided by 2 n exponent 5 n squared, and we then subtract 5 minus 2 in the exponent for the n, do the division 4 over 2, and we end up with 2n cubed. Next example, 5y exponent 8 divided by 10y cubed. You kind of begin to see maybe a pattern. We're not going to do the expanded form. We're just going to take a look at what happened here. So we rewrite this if we want. 5 divided by 10 multiply. Now that the base is the same, I can subtract the exponent. And please notice that we subtract the exponent in the denominator from the exponent in the numerator, not the other way around. So we are doing x minus, y to the exponent 8 minus 3, which is 5. So this is 5 tenths times y exponent 5. And of course, we can simplify 5 tenths to 1/2 y exponent 5. Last example. So here we have negative 20 x exponent 4 divided by 4 x to the power of 1. So we now can see very quickly that negative 20 divided by 4 is negative 5. So this example is different because it incorporates the sign rules. So negative divided by a positive gives us a negative. So 20 divided by 4 is 5, negative 5, and then we subtract 1 from 4 in the exponents, so x to the power of 4 minus 1, and at the end we arrive at negative 5x cubed. So here's the rule that we want to remember. When coefficients are part of the quotients and of the monomials that are being divided, you divide the coefficients and then use the quotient rule to simplify the powers. Good. So now we're going to do another puzzle, just like we did for power rule. I hope you enjoy these puzzles. These are interesting, and we're going to do just one example because quotient rule could be a bit different. So same logic as before. We have the green piece puzzle and a yellow and a blue that would fit, but we have to choose between which yellow and which blue. So let's read the instructions and then figure out the puzzle. Which expressions are equivalent? Complete the puzzle by clicking on puzzle pieces that contain equivalent expressions. So here's the expression inside our green puzzle, which is negative 8x squared y exponent 5 divided by 2y cubed, or y exponent 3. So when we apply what we just learned, let's think of the coefficients, and the division of the coefficient is going to be negative 8 divided by 2, which is negative 4. And then let's see what happens with our variables. There's no x squared or x at all in the denominator, so we can leave the x squared as is, and then the y has exponent 5 in the numerator, 3 in the denominator. That means that we would subtract 5 minus 3, and we arrive at our answer that would be negative 4 x squared y squared. So let's see if we have that. We have here negative 4x squared y exponent 8, which would be incorrect because we don't add them, we subtract them. So we think is this one, and there it is. And now we have to evaluate. Now we have blue. Look at the blue pieces, and we're going to see what happens when the value of y equals 2, and what happens to our expression. So when the value of y equals 2, that means this expression would be y squared or 2 squared, meaning it's 4. This is replaced by the value of 4. And we multiply 4 by negative 4, we end up with negative 16x squared, which is this piece. And we click on it, it joins the puzzle, and let's see how we did. Correct. If we hadn't gotten it correct, we get feedback and we have to try it again. Now you will try a few of these, try 5 or 6, and have fun with them.